The skyscraper puzzle. In this puzzle, we have an n by n grid, which is initially empty. The numbers on the borders show us which number to place inside this grid. We are gonna place numbers from 1 to n to this grid, and for every row and column, we are only gonna use the same number for once. You can think of the numbers as the apartments. So basically, 4 means the tallest, and 1 means the shortest apartment. The way you are going to place these numbers is that when you look from a specific perspective, you're only going to see a specific amount of apartments. Now, let's do an example. Let's select this to be our perspective. And when we look from this, you're only going to see one apartment because one is written on the border. We know that we have numbers from 1 to 4. And based on the information that was given, we know that we can place 4 in this square, because when you look at this perspective, we just want to see just one apartment, and when you place 4 in there, whatever you put after that apartment, you are not going to be able to see it, because we know that 4 is the tallest apartment and it will block your view. When you fill the board, it will look like this. Now let's do one more example. Let's select this to be our perspective. So basically we need to see just 2 apartments when we look from this perspective. And as you can see, we can only see 3 and 4 when we look from this perspective. We can't see 1 because 3 is blocking our view. We can't see 2 because both 3 and 4 is blocking our view. Now that I've explained the rules, let's do some coding. When I searched on this problem on the internet, I found this GitHub page in which when you enter a specific board, it checks whether there is an existing solution, and if there is, it prints that solution out. Well, I needed a program that would find the boards itself, not the solution. So after some engineering like a professional, I have ended up with this code which basically finds all 5 times 5 boards in just a single run using backtracking. And then as you can see, I generated my solutions. And now that I have my data, I need to build up a structure for my machine learning model. I first decided that I would be using the graph neural network, which is really good when if you are considering to solve a puzzle using a machine learning model. And that is why I started to search about this graph neural network. In graph neural network, you are first defining the relationships of the nodes together. And one example of this machine learning problem would be that predicting the topic of a research paper based on the citations of this specific research paper. We know that for every row and column, we are only going to use the same number for once. So if we link these squares together, and if we pass these links to our machine learning model, it would learn that we are going to place the same number for once for every row and column. And if we do this to every row and every column, then our machine learning model would easily learn about these rules. In my model, I used 5 times 5 grid, unlike I showed you the examples. And I had around 160,000 test values to train my model. Well, this is the full code, and let's analyze it. We have libraries installed, imported, we have seed, we have load data, and we have create graph from puzzle. So this is important. And as you can see, this edge index is where we assign relationships between nodes, between variables. So this is important, and this is basically the reason why I used graphs, because it allows us to make connection between nodes. And as I explained before, I made connections between every value in the same row, and this is just the calculation part, which we calculate the edge indexes, and we have grid x, we have x is the input, y is the output, edge index is the relationships between nodes. And let's see We have training. So I use 95% of my data into training. I put 95% because I have over 160,000 values. So I thought even though I use 95% on training, there would still be enough for testing, for validation. And I used batch size of 32. Let's see. And this is important. Custom puzzle loss. We use mean absolute error and we add this with uh, with this loss, which I define here. So this basically counts the amount of same value occurring in the same row or in the same column. So if the same value occurs twice in the same row, this total will be 1. And we add that to, we say that is the loss due, and I have assigned a weight of 0.1 to that loss. Additionally, I have this if out of bounds, meaning that if this model generates a value that is not in range, so it should generate values in between 1 and 5. If it generates something more or less than these values, then I add 1000 to my losses. So this 1000 is just a value that I came up with, and if I put like 10, it might have been better, but I just did put 1000 in there. And this is my complete model. Puzzle graph neural network. I have used attention layers and normal convolution layers, graph convolution layers. And this is basically the structure. I created dropout layer, which I didn't use. I tested a couple of times with these dropout layers, but then I decided I won't use them. And then we have these linear layers back to back. I used ReLU activation function, and I also round my values because we need values that are integers. Let's see, as I said in this video previously, I used the ADAM optimizer with a learning rate of 10 to the negative third power. And this is the training part. I trained it a total of currently 20 epochs. I used mean absolute error for the 15 of these epochs, and 5 of those epochs were for I used mean square error in here. So I was originally planning to use mean absolute error, but I then decided that what if I use mean squared error loss? And let's see. And this is the evaluation part. So let us evaluate. I'm gonna comment this training part out as well as the save. Let me run this and see the result. We generated our solutions. So these are the constraints. They appear to be single array because that's how I trained my model. And as you can see, this is the solutions, and it just printed minus zeros. Well, it is bad actually. As you can see, it printed minus zeros. It didn't even print numbers that is in range 1 to 5. It just printed 0, and that's actually bad, meaning that our model is not learning anything. So we can conclude that this model is not efficient for this skyscraper puzzle. And then after I saw that this didn't work, I used convolution layers actually, and I trained this, I guess, for 30 epochs. And then I used like convolution layers back to back. I also used some residual learning hoping that it would make my model better. Apart from that, I think everything is the same, except in the custom puzzles we don't have the plus 1000. I guess I didn't put it in there. And when I also run this, it also did print zeros. So this convolution layers also didn't work. And I mean, I generated two different models which both didn't work. I guess we might need a more complicated model to solve this problem, or maybe another model type, maybe. I want to end this video by concluding that if you can do something without any machine learning model, do it without any machine learning model. And that's what I heard from a person that was familiar with these machine learning models. And that's actually right. I mean, why do we even use machine learning model to solve this problem? We can just calculate it using backtracking in milliseconds. I just wanted to see whether these models would work, which obviously didn't work. And that's basically it for this video. If you have any question, please leave a comment and have a great day.